Hello, friends. How are you all? I'm sure you all are doing good. So, topic for today, as you have seen already, is logarithms. Yes, you heard it right. Logarithms. Yeah. So let's explore everything about logarithm. One of the very important topics for many entrance examinations. Okay. All right. 10 square, 100, right? 10 cube, 1000. 10 raised to what is 1347? So 10 raised to 1, 10, 10 square, 100, 10 cube, 1000, 10 raised to 4, 10,000. We all are very, very comfortable with these powers of 10. But have you ever thought about it? What if I have 10 raised to something is equal to 1347? Did you ever wonder about this? Did you ever think about this? There should be some number in the power of 10 which will also give us 1347 as the answer, isn't it? Okay, let's see. So 10 raised to something is 1347. One thing is very clear that 1347 is above 1000. Yeah, it is more than 1000 and less than 10,000. Means, if you understand now, that the power x, which is unknown as of now, must be something between 3 and 4. Yeah. So 10 raised to x is equal to 1347, and we are trying to find that x. At least we have some judgment that x will be between 3 and 4. All right. Because the value 1347 is above 10 cube and below 10 raised to 4. So power should be 10 raised to 3 point something. Okay. 3 point something means, can I split that further? So 3 plus 0 point something. Yeah, let me use more technical words, technical terms. 3 will be like the integer part and 0 point something will be the decimal part. Yeah, so integral part is 3 and decimal part is 0 point something. So 3 will be called as characteristic and 0 point something is called as mantissa. Yes, the integer part is called as characteristic and decimal part is called as mantissa. Characteristic we have to find on our own and we can easily find it. Yeah, but mantissa, for mantissa we need log table. Okay, so don't worry for mantissa. We need log table for that. We can find it from there. Okay, comfortable till now? All right, so this was like why we are learning this topic. Okay, so 10 raised to x is 1347, and answer for that x, the value of that will be, the value of x will be nothing but log of 1347 to the base 10. Let me repeat once again. Yes, friends, log is the short form of the term logarithm. Yes, you guessed it right, correct. So log of 1347 to the base of 10. This is how you should read this. So from that particular format, which was 10 raised to x is equal to 1347, which I will call it as index form or power form or exponential form. I converted that form to this particular form, wherein you can see the log. So I'll call that as logarithmic form. All right. Or in short, log form. Yeah. So log of 1347, the answer will be 3 point something, where 3 is characteristic and 0 point decimal part will be mantissa. All right. Okay. Comfortable till here? All right, cool. Thank you. Okay, so let's move ahead. So that the first pillar or the first point was about introduction and why are we learning this logarithm. I'm sure you understood some logic that we are learning this because we want to find that unknown power. 10 raised to what is 1347. So that unknown power is nothing but log. Okay, conversion. Second pillar is conversion. Just now we saw something about it. So if I have a to the power x, a is called as base, isn't it? X is power or index or exponent. There are so many words. These three terms are there for power. Okay. Now, if a to the power x is equal to b, this we will call it as index form or power form or exponential form. All right. Yeah. Now I convert this to other form. Yes, that is your log form. Yeah. So a raised to x is equal to b is ultimately index form where you see three terms: base, power or index or exponent, and b. What should we call that b as? Yes, no technical term. You can call it as answer. So answer of a raised to x is b. That's it. Now, if you want to find that x, you need to convert from this form to other form, and that form is log form. What is that log form? Check this. X is equal to, don't you think we were going to find the value of x only, right? So x is equal to a log of which two terms? B to the base a. B to the base a. B generally I call it there as answer, but technically you can call it as argument. Yeah, correct. So how to read this? Log of b to the base a. All right. Cool. How should I remember this conversion comfortably? One thing will not change. What? Base. Did you see the base in the case of index form? In case of index form, the base was a only. In case of log form also, the base is same a. Base doesn't change. Base remains base. Yes, that's the keyword. That's the golden line in yellow color in front of you, friends. Remember this line. This will help you to convert from log form to index form to log form. Both ways. Yeah. So from log form to index form, if you want to do, start from this base only. A to the power this x, so a to the power of x is equal to b. Okay. A to the power x is equal to b. All right. Yeah. Comfortable? Understanding? Thank you. All right, friends. Let's explore some examples and some small results based on this thought of conversion. Okay. 10 cube 1000. Come on. Which form? Yes. Index form. Okay. Index form. Convert this into log form. Base remains base. So 3 is equal to log of, yes, 1000 to the base 10. Correct? Next, x is to y is equal to z. Come on, think quickly. Yes, base में तो x रहेगा. So y is equal to log of z to the base x. Understood? Yeah. Log of p to the base q is equal to r. Now I have given you log form. I want to convert this into index form. How will you start? Yes, that base is q, isn't it? And power will be r, because power becomes answer na, is equal to के बाद आता है वो. So q to the power r is equal to p. This will be the index form from log form. I hope slowly and steadily the thought is sinking. Cool. Now some small results, very useful, handy results. A to the power 1 is a, of course. Which form? Correct. Index form. Can you tell me the log form of this? Yes. 1 is equal to log of a to the base a. Remember this. So whenever the argument and the base, both of them match, answer is 1. Isn't it? Cool. Yeah. Second one, a to the power 0 is equal to 1. This we know already. So index form we are already familiar with. We're just learning when the same thing is expressed in the world of logarithm, what will it be? How will it look like? Okay. A to the power 0 is 1. So log of 1 to the base a is equal to 0. So when you're getting 0 marks, घर पे क्या बोलने का? I got log 1 marks. So you were not wrong, but you just change the format. All right. Third one. Sorry. If you know a raised to x is equal to b, this is our index form. When we converted this into log form, so x is equal to log of b to the base a. This is log form. अब तक कब से यही करते आ रहे हैं. Can I club them? Means in that a raised to x, in place of x, can I write log b to the base a? Yes, we can. So a raised to x, in place of x, I wrote log b to the base a is equal to b to tha hi na. So how will you remember? When the original base, this one, and the log ka base, that is a, both of them match, answer is that argument, that is b. Okay. For example, 3 to the power log of 10 to the base 3. So what will be the answer? Yes, both the threes match. Original base and log ka base, both of them are same, so answer is 10. Superb. Great. Fourth one, if you see this structure log a equal to log b, you can simply remove log. You can say that then a must be equal to b. This is called as removing log, friends. Removing log. Yeah. And vice versa is also true. That is, if a is equal to b, you can take a log on both sides. ऐसा मत बोलना multiplying by log on both sides. That is wrong. The wrong thought. Taking log on both sides, applying log on both sides is the correct terminology. और वो log a equal to log b है जो a equal to b आया ना, you can't say log cancel. Hello. Okay, that is a wrong thought. Removing log, or it is obvious that if log a equal to log b, then a must be equal to b, provided both of them have same base. All right, understood till here? Great. I'm sure you're comfortable till here. Let's go ahead. Next point is point number 3, types of log. Yes, types of log. Two types of log. One natural log, other one common log. Natural log, when the base of the log is e. You know, when Mr. John Napier discovered this thought for the first time, he used the base as e. So that is why this log came into nature first, hence the name natural log, or you can also call it as Naperian log for his respect. The symbolic form of this is ln log. In your calculators, you can see this symbol ln. We read this as log natural. Okay, log natural. So when the base is e, it is ln for a Naperian log. Okay, then common log means base is 10. Standard base is 10. So for all calculation purposes, we use this log. Base is 10. All right. Also called as Briggsian log because Mr. Henry Briggs converted from base to base 10. You know, your log tables, all the values are there, which are on the basis of base 10 only. Okay. So log 10 to the base 10 kya hoga? If you just see log 10 in calculation, so by default you can assume base is 10. Argument and base, both of them matched. Remember, log a to the base a is 1. So iska answer bhi 1 aayega. All right. ln e. Come on, ln e. ln means log of the base mein e. So log of e to the base e. Again it matched, isn't it? So answer is 1. So ln e padhte hain. ln e log natural. So ln x, ln x. Okay. When there is no base and it's a calculation based question, we are allowed to assume the base is 10. Now, log x to the base e means ln x, ln x is equal to 2.303 times log x to the base 10. This is the conversion factor where e is nothing but an irrational number like pi whose approximate value is 2.72. Okay. This is something extra. Even if you don't know this, it is fine. Okay. All right. Understood types of log: natural, common, base e, base 10. Cool. Let's go ahead. So for the next point, the fourth point is conditions on log. There are some logical conditions on log, you know, for log of a to the base b to exist. There are two by default conditions, very important to know while solving the questions. You know, sometimes one of the answers will be eliminated because that value will not satisfy this condition. So that is what is important to know that. So the two conditions are, here we go. First one, the base can never be 1. You'll understand this after some time when we learn the rules or the laws of log. There I will make you understand why base cannot be 1. Second, the argument and the base both should be positive. Okay, both should be positive. Then only the log will exist. So log of 0 not defined. Log of negative number not defined straight away. Log of 7 to the base 1 not defined. Yes. Okay. All right. Comfortable? ठीक है. So finally, the most important moment of the topic, laws of log, means the rules of log, the main formulae. This will be most frequently used in all the questions based on logarithm. So till now we have done all the background, the foundation, yeah, about log. Now this is the main part of the log, friends. Please be very careful. Let's do it. Yeah, chalo. First rule, it's about product. Log when applied to a product of the numbers. So what's the answer? How does it take? How does it move forward? When you apply log to the product of the numbers, how you open the bracket? So it will be sum of the logs, log of A, the first number, plus log of B, plus log of C, plus log of D, and the next number, and so on. So how do we read this? Log of product is sum of the logs. Okay. Log of product is sum of the log. Yeah. Similarly, you should be comfortable in reverse manner also. That sum of the logs is when you merge the logs, then it will be log of product. Generally we get emotional and we think here like this. Log common ले लेने का. Log common लिया तो अंदर a plus b plus c आएगा. Wrong है. Log common का thought ही नहीं होता. So log a plus log b plus log c is log of a into b into c. This thought should be very, very clearly understood. Okay, friends, clear? Thank you. Second one, when you apply log to a division process, numerator divide by denominator, how will this open up? Yes, it will be difference of the log. So log of numerator minus log of denominator. All right. And vice versa also should understand properly. When you see log minus log, so you can merge it as log of division, numerator divide by denominator. Okay. Yeah. Cool. Third rule is log of a raised to m. Actually, if you see carefully, a raised to m is nothing but just another version of the first rule, isn't it? In the first rule, log of a into b into c, different numbers were there. If all of them would have been same numbers, a into a into a into a into a, m times. Don't you feel we'll write it as a to the power m, isn't it? Yes. So how will it open up? Log a plus 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 log a m times. And in short form, how do we write this as? M times log a. Yes. Samjha? Done? Now, one emotional mistake which we can do here. Log of 3, the whole square, huh? The whole square. What does that mean? Log of 3 into log of 3. Will it be 2 times log 3? Generally, we have a habit of understanding that a to the power m में वो m आगे आ जाता है. m आगे आके m times log a हुआ. तो इधर भी वो 2 आगे आ जाएगा. So 2 times log 3. नहीं. Log 3 the whole square means log 3 into log 3, and 2 times log 3 means log 3 plus log 3. How can they be equal? So 100 into 200 is not same as 100 plus 200. All right. Easy. Cool. So see the structure carefully. What the structure is. Then don't do such silly mistakes. All right. Thank you. Next one. Finally, log of a to the base b. Actually, this rule will tell you the real meaning of log. Logarithm is actually derived from two Greek words, logos and arithmos. Logos means ratio. Arithmos means numbers. So ratio of two numbers. Which two numbers? Yes, first number is log a, second number is log b, and ratio means division. And there I have just put a new base as x. Okay, here in this formula, what are the terms involved? You can see a, you can see b, you can see x. All of these are positive, first of all, and b and x, the numbers which are present in the bases, cannot be 1. Let's discuss. You remember I had told you why base of log cannot be 1. I will explain you later. So remember what is log 1? Come on, recall. Yes, you are right. Log 1 is 0. Just imagine if that b is 1. So denominator will be log of 1. So denominator is 0. Denominator 0. Is it possible? No, right? Division by 0 is not defined. That is why that base can never be 1. I hope you understood. Based on this, one more simple logic. What about this log of a to the base b multiplied by log of b to the base a? Think. Superb. Lovely. Log of a divided by log of b into log of b divided by log of a. So both are reciprocals of each other. Ultimately, answer is 1. Isn't it? Yeah, whenever the product of two numbers is 1, both are reciprocals of each other. It means log of A to the base B is reciprocal of log of B to the base A, isn't it? All right. So log of A to the base B is 1 over log of B to the base A. That is what we discussed just now, right? Both are reciprocals of each other, isn't it? So if you see 1 upon log, then this thought should click. So 1 upon log of 10 to the base 3, what will it be? Correct. Log of 3 to the base 10. Awesome. Argument and base can be interchanged, isn't it? Comfortable? Okay, let's go ahead. One more shortcut rule I must say. Whenever you see this kind of term, a to the power something, and in the base also there is a power form, b to the power something. So a to the power alpha, and in the base we have b to the power beta. So what to do? Both the powers will come ahead, that is alpha upon beta, and then you are left with what? Log of a to the base b, isn't it? When alpha and beta will move ahead, what remains? Log of a to the base b, isn't it? All right, इसका proof देखना है. Let's see. What will be the first step out of those four laws? Those are the four important major laws. Main वही है चार, उसके help से सब derive हो रहे हैं. Yeah. Of course, you will use that change of base rule, right? Yeah. Log of a to the base b was log a upon log b. हमने एक नया base डाला था x. So पहले base b था, बाद में base x हुआ. So it is also called as change of base rule. All right. Base got changed. So here also I will do that only. Log of a raised to alpha. And in the denominator, log of b raised to beta, logos and arithmos, ratio of two numbers. Okay, log of argument upon log of base. अब क्या? Can you see a raised to alpha, b raised to beta? So third rule, a raised to m wala rule, a multiplied m alpha times. So alpha will be coming ahead. So alpha will become coefficient. Alpha times log a divided by beta times log b. And log a upon log b can again be merged as, yes, log of a to the base b, isn't it? ऐसे derive हुआ. I'm just skipping these two steps in between them. So यहाँ से यहाँ पे directly लिख रहे हैं हम लोग. Okay. Understood. Log of a upon log of b. I hope यहाँ पे ये thought तो नहीं है ना, log a minus log b. This is not log of a upon b. This is log a divided by log b. Fourth rule. तो log of a to the base b को लिखा था ना log a upon log b, तभी reverse लिखा. Log of a upon log of b is log of a to the base b. Okay. All right. Example. Log of 5 raised to 20 to the base 7 raised to 10. तो क्या? Yes, 20 and 10 will come ahead, and log of 5 to the base 7 will remain. Means 2 times log of 5 to the base 7. समझा? Okay, one more example. In this case, what do you feel, friends? Yes, 2 and 1 will come ahead. Log of 5 to the base 5 and log of 5 to the base 5. Amazing, very easy. It's 1, right? Okay. Log 1 marks मिला था, उधर डिस्कस किया था कन्वर्जन वाले थॉट में, बराबर. Okay. One more structure. X raised to log y, and this is last one. No, relax. Can also be written as y raised to log x. Yeah. So which means this x and y can be interchanged, but base should not be disturbed. Okay. Yeah. For example, 3 to the power log 5 to the base 10 can also be written as, yes, 5 to the power log 3 to the base 10. Amazing. Got it? Understood? Okay. All right. Now finally just have a look at the graph of log. How does the graph of log look like? So I'm drawing the graph of y is equal to log x. Y means f of x only. And base is a. So here x and a both should be positive. A is not 1. And I'm drawing the graph especially for a more than 1. This is how it looks like. Yeah. It will cut x-axis at 1, 0. You can verify easily. When x is 1, y is what? Log of 1 to the base a, and log of 1 means 0. Yes. So did you see between 0 and 1 graph went below x-axis, means y is negative over there, isn't it? You can obviously verify If I take log of half to the base 10, log of half means 2 raised to minus 1. 2 raised to minus 1 means minus 1 आगे आएगा. So log of 2 is a positive answer to the base 10, 0.3010. log table से check किया and आगे negative आया. So negative answer, right? Correct. Or you can also look at it as log of 1 minus log of 2. Log of 1 is 0 minus log of 2. So minus of log of 2. मतलब वही minus of 0.3010. Okay. All right. Now just summarizing the last point. Ultimately crux of the matter in the questions, we will be mainly dealing with two thoughts. Sometimes we'll have to apply log, bring log into the picture, introduce log, and sometimes we need to remove log. Majorly यही दो thought होगा. Okay. So to bring log in the picture, so you should have A equal to B kind of structure. Apply log on both sides, take log on both sides, log equal to log B. So you have introduced log. Similarly, index form में arrange करो सब कुछ, A raised to x equal to B के format में, and then convert that into log form. That is x is equal to log of B to the base A. So again, we have introduced log. Okay. Now to remove log, similarly, we have two choices. Convert into index form. The log form दिया रहेगा, उसको standard structure में arrange करके index form में convert कर दो, base remains base, याद है वो सब. And then if you have log A equal to log B kind of format, then simply you can remove log. So A is equal to B हो जाएगा. ठीक है. और एक choice है, उसको बोलते हैं anti log, but we are not dealing with pure numericals. It's okay. So these two thoughts are enough. All right. So I hope you understood, friends, whatever we discussed in this logarithm. This much is the bare minimum concepts which you should know to approach any question based on log. Yeah. Okay. So please see this video again and again till the time you feel very, very comfortable. So we'll be solving more and more questions when we meet. Thank you so much. Take care. Stay safe.